Hi again, everybody, and welcome to section 2.5, solving for a variable. In this section, what we're going to be doing is solving for a formula for a given variable. So we're going to have a formula set up here, and you're going to have to solve for one of the letters, one of the variables that's in the formula. And to continue here, solve an equation in two or more variables used for one of the variables. So there's going to be two or maybe even three variables in a formula, and you're going to have to solve for one. It's really important that we do this because it's definitely on the keystones. It's definitely in real life, and this is a really important lesson for us. Here's some warm-up questions. As always, pause, go over them real quick, come back, grab the answers. So for number one here, we're solving for x. And x is going to be, we're going to move the 5 over, it's -2 minus 5, and that's going to be -7. X is -7. Number 2 here, 8m equals 43. Well, we're just going to simply divide both sides by 8. So m is going to be 43 over 8. Number 3, a little bit, it's a two-stepper here. First, we're going to have to get rid of the fraction by multiplying both sides by 4. So you'll end up with this canceling out, and you're going to have c plus 5 equals 24, and then bring this over and make it a -5. So c is going to be 19. Number 4 here, move the 0.6 over and then divide. Your answer here, s should be 3. And then for number 5, moving things side to side here, k is going to be equal to 8. So I hope you did well on those. So let's clear these out of here. And what we're going to look at here at first is a formula. Now, a formula is an equation that states a rule for a relationship among quantities. Here's one of the most famous ones here in the formula: D equals RT. D is what they call isolated. It's all by itself. Now, this formula is distance equals the rate times the time. And usually when you have two of these numbers filled in, you're trying to find the third one. So how fast can I go for how long and be my distance? That's how this would be set up. But if you wanted to find, say for instance, the time, you would have to take the distance divided by the rate, and we'll be doing that here in just a second. So it's just a step-by-step help here. Locate the variable you're asked to solve for. Identify what you have to do to get rid of everything else and leave that variable all by itself. And then we're going to use those inverse operations to solve and get that variable isolated. So here's our first one here. This is very famous geometric formula. This is c equals pi times d. And what this is a formula of is c is the circumference of a circle, the distance around the circle, and d is the diameter of the circle. So what you're asked to find here is the circumference of the bowl is 18 inches. What is the bowl's diameter? So we have to find d. And there's two ways we can go about doing this kind of equation, but we're going to go and do the most typical way, and that is going to be just solve for d first. We'll do that. So I have c equals pi times d. If you're unfamiliar with pi is just a number. Pi is 3.14159. I'm sure you've seen it before. 3.14159. Well, we just represent it with this symbol here, pi. So what we're going to do is we're just going to assume that, okay, this is just a number times a variable, nothing different here. This is multiply. So I have to get rid of a multiply. I got to move this over here. Well, how do we get rid of multiply? Well, we divide. So I'm going to take this pi over, actually I'm going to drop it down here, and turn it into a division and get rid of it. Or I could have also done this here and say, well, since I'm multiplying by pi, I'm going to divide by pi. So either way you look at it is fine. Those will cancel out, so c divided by pi is going to be my diameter. So now what I can do is I can take this formula and plug in what we know from the word problem that says the circumference of the bowl is 18 inches. So where c is, I'm going to plug in 18. I still have pi here, and then answer is going to be d. Now this says leave it in terms of pi, so they're not asking to divide 18 divided by 3.159. They're just saying leave it as this. 18 divided by pi. Don't divide it in. So that's what you're looking at whenever you're solving for a variable. You're trying to get d isolated, and d was here. So to do that, I had to do the inverse. Since I was multiplying, I had to divide and get rid of the pi and have my d isolated all by itself now, and then I have a new formula on the left solving for d. Let's take a look at another example. This one, again, the formula D equals R times T, distance equals the rate times the time that you're traveling. Find the time in hours that it would take Ernest Van Dyke, whoever that is, to travel 26.2 miles, the length of a marathon, if his average speed was 18 miles per hour. So he's either riding a bike really fast or he's running fast, like super fast. So what I'm going to do is I'm going to write that formula here. D equals R times T. Now again, I'm trying to find the time. That's what I'm asked to find. What is the time? So that means that I'm going to be isolating that variable t. So that means the r has got to go. I want t by itself. So once again, we have r being multiplied into t. So how do I get rid of the multiplication? I do the opposite. I divide. Okay, just like numbers. We're just using variables now. These r's are going to cancel out. And now I'm left with t on my right side, all by itself, which is what we wanted. Distance divided by the rate. So if I was going to travel, how long would it take me to get to, I don't know, Ocean City? That's something like 400 miles away, and I'm going 60 miles an hour. How long would that take? Well, this is how you would do that. But this we're trying to find out the distance is going to be, let's substitute some values in here, 26.2 miles divided by our rate of speed, which is 18 miles per hour, and that's going to give me the time. So I'm just going to pull out my calculator. And I'm going to divide 26.2 divided by 18, and I'm going to get 1.45. So 1.45, almost an hour and a half for my time. Okay, so that's how that works. There we go. Let's look at another one here. Another geometric formula here. Area equals 1/2 base times height. This is for the area of a triangle. So it says B is the length of the base and H is the height. Solve for H. So this one we don't have any numbers. So we're just going to find H all by itself. So let me rewrite the formula here. Base times height, and I'm isolating the H. Okay, so this means everything else has got to go. The 1/2 and the base. So first thing is always tell you to do is get rid of the fraction. So since we're dividing by 2 or multiplying by 1/2, I'm going to go back and we're going to do the reciprocal here. I'm going to multiply both sides by 2 over 1. Okay. Now if you want to, if you like to clear this out, make this a little bit easier for you. A lot of people like to put a little space here. And write the 2 over 1 here. That's okay too. Okay, since these are inverses, they're going to cancel out. So down here, next line, I'm going to have just the base times the height. And then, remember that A is going to be over 1, just like always. So we're going to have 2A over 1, which is just 2A. So I'm not going to write the over 1. Okay, now I got to get rid of the H, and this is similar to what we just did prior. I have a multiply here, so to get rid of that B, I got to divide it. So that goes away there, and over here I have to do the same, divide by B. So in the end, I'm left with H equals 2A divided by B. Okay, I'm solving a problem like I've always done here, just letters this time instead of numbers, but it all works the same. Isolating that one variable that we want. Here's again the H that we needed. Getting everything else on the other side, using our inverse operations. Okay, this is another very important formula. This is the speed of typing, your typing speed. So S is found by taking W, the words typed, minus 10 times E, and dividing all of that by M, the number of minutes typing. So this one wants to solve for E. This one's going to be one of our more trickier ones that we've done, and that we may do actually. So I'm going to write this one. I'm going to write a little smaller here. S equals W minus 10E, all divided by M. And we're trying to find E. Okay, so what we're going to do is we've got to get rid of fraction. Number one, always get rid of the fraction. So since we're dividing by M, let's multiply both sides by M. And that takes care of this division. So on my left side here, I'm going to have M times S, equals W minus 10E. Okay, so I'm still looking for this E here. So I'm going to get rid of the W. I'm going to bring this over. So what I'm going to have is, once I move this over, it's a positive W. On the left, it's going to be a negative W. And that's going to be a plus MS. That would have no sign that they're negative, so they'll be positive. So now once I do that, so that's gone. Negative 10E over here, and then negative W plus MS on the left. So the last thing I want to do here is I'm trying to still get E alone, so that means I have to get rid of that negative 10. Well, since it's multiply, I got to do the opposite, which is negative divided by negative 10. And you got to do the whole thing, not just W, not just MS. You got to do the whole thing. Divide by negative 10. So this cancels out here. The negative 10 and negative 10 are gone. So I'm going to write it over here to my right. I'm going to have, all over the fraction, negative W plus MS divided by negative 10 equals E. Now that was a lot of inverse operations, but I hope you're starting to get the hang of this. We're just trying to get everything on the other side by doing its inverse. Okay? Here's another neat formula. The formula for an object's final velocity, that's the speed it's going, which is f, is equal to I minus gt. Now I is the object's initial velocity, how fast it was going when you started. G is the acceleration due to gravity, which is usually 9.8 meters per second or 32 feet per second. And t is the time. So we just want to get I by itself, and this one's not going to be too bad. We're going to have, I'll rewrite it here, f equals I minus gt. And once again, I need to find I. I'm going to get I alone. So this isn't going to be too bad. Actually, all I'm going to do here is get rid of this gt. I can do this all in one step, actually. Since this is a minus gt, I can bring it over here and make it a plus gt. And that's a plus f. It's not negative, so it's going to be positive. So in the end, after one quick step, gt plus f equals I, the initial velocity of the object, whatever it is. So that one wasn't too bad. Got I all by itself and everything else on the other side. That's all good. A couple more here. Again, this is x plus y equals 15 for x. We're just solving for x, not a big deal. So I need to get x all by itself, which is right here. So that means I got to toss the y. So I bring it over to the other side here. When I do, that's going to be a minus y. So in the end, I have x equals 15 minus y. Down here in the next one, pq equals x, and we're going to solve for q. So let's see, here's q. And the only thing I have to do is get rid of that p, and since they're multiplying, I have to divide. So I'm going to divide both sides by p. Those go away. I get q alone on the left. And over here, I'm just looking at x divided by p. Plain and simple. Here's another one here. Solve. We got 5 minus b equals 2t for t. So to get t alone, you don't think over here, here's t. All I have to do is get rid of this 2 in front. Again, that's a multiply, 2 times t. So I have to just divide. So I can do the whole side. So I'm doing this and this. So all I have to do now is this entire side and divide it by 2. So I'm left with 5 minus b, all divided by 2 equals t. There we go. Okay, here's another one here. This is d equals mv, and I'm trying to solve for v. Now this one's going to be a little different because v is actually on the bottom, and you can't have it on the bottom. It just doesn't work. So let me rewrite this. I'm going to do d equals mv. There's not much we can do here other than this step. Remember, rule number 1 is always get the fraction, get rid of it. So to do that, I actually have to multiply, not by w, by v on both sides. Even though we're solving for that, we still have to get rid of the fraction first and foremost. So now those are gone. V times d is just going to be v, capital D, equals m. Well, I'm still out to hunt for this v, and I need that to be alone. So that means I have to get rid of the D now, this capital D. So I'm going to divide both sides by capital D. Get rid of that, get rid of that, and now I'm left with V on my left, and then on my right side, this M divided by capital D. Okay, so that one was a little more complicated because you had to get rid of the V on the bottom of the fraction. But once you do that, you just divide by the capital D, and then you have it, M divided by D. Okay, so that's the end of this lesson. It was a little shorter. Here are some practice problems to finish up the lesson. Please let me know how you do. If you have any questions, let me know. Thanks so much for watching, and have a great day.